Hello everyone, my name is Nikita and I am from the Bodhi Academy. In the last video, we had started and we had continued with the chapter Metals and Non-Metals from 10th Standard Science textbook. Today we are going to continue with the further parts of the same chapter. Okay, today we are going to see how the metals are reacting with non-metals. Okay. Okay, so here we need to know that the metals react with non-metals to form something called as ionic compounds. Okay, to form something called as ionic compounds. Ionic compounds are the ones which share an ionic bond. Okay, it shares a ionic bond between the metals and the non-metals. Okay, now to study this we need to study the formation of a ionic compound. So here I will take an example of a compound which is NaCl, that is sodium chloride. Okay, sodium chloride. Now over here the metal is sodium, okay, and the non-metal is chlorine. Okay, so to study the formation of a ionic compound we need to study from the depth. Okay, we need to form the compound. Okay, so we need to execute from its atomic number. So here we know that the atomic number, okay, the atomic number of sodium is 11, okay, and the atomic number of chlorine is 17. Okay, atomic number means the number of electrons or the number of protons. Now protons are present in the nucleus and electrons are present in the shells, and the atoms have shells which are K, L, M, N. Okay, so now over here we will see the electronic configuration of sodium first. Okay, so as it has 11 electrons, the electronic configuration of sodium becomes 2, 8 and 1. Okay, and electronic configuration of chlorine will become 2, 8 and 7. Okay, so now what is the valency? Valency is the number of electrons which the mostly present in the outermost shell, or the number of electrons required by the atom to gain a complete orbit. So over here the valency, that is the outermost shell electron, that is, this is the K shell, this is the L and this is the M shell. The outermost electron present over here is 1. So the valency of this sodium becomes 1. Now over here the valency of chlorine. Okay, now for the for chlorine to attain a complete filled valence shell, okay, it has to take an electron. So it has to take 1 electron. So the valency of chlorine also becomes 1. Okay, so now from here we can observe that sodium will lose this electron. Okay, sodium will lose this 1 electron and chlorine has to gain 1 electron. Okay, sodium has to lose 1 electron and chlorine has to gain 1 electron. Okay, so now when a atom loses an electron, it gains a positive charge. We know that the protons present in the nucleus are 11. Okay, and when the sodium will lose this electron, the electron number will turn into 10. Okay, so this nucleus now gains a positive charge. That's the reason we write sodium, after it loses its electron, we write it as Na plus. Okay, Now in this case, the chlorine is gaining the electron. Chlorine will gain the electron, and we know that the number of protons present in the chlorine atom is in the nucleus of the chlorine atom is 17. Okay, and after gaining one electron, the number of electrons will be 18. Okay, so the proton has one less. Okay, the proton has one less charge. Okay, one less charge. That's the reason the chlorine gains a negative charge after it has gained an electron. So the sodium gains a positive charge and chlorine gains a negative charge. Now how do these two combine? Okay, how do these two combine? This will lose one electron and the electron lost. Okay, sodium will lose its electron. Sodium will lose this valence electron, and the electron lost by sodium, okay, will be gained by chlorine. Okay, this is how they form the ionic compound NaCl. So it is represented as, first we write Na. Okay, sodium has one electron. So over here we represent just the last shell, the valence shell. So over here it is the one electron which is present in the sodium in the last shell, that is represented by a dot. Okay, now the next is chlorine. Okay, so for chlorine, now it has, the last shell of chlorine has 7 electrons. Okay, so we will represent it in the form of crosses. And 7. Okay, so now there are 7 electrons over here. So over here, this electron which is lost by sodium will be taken by chlorine, and therefore they will form a compound called as NaCl. After it loses, it will gain a positive charge. Okay, and after the chlorine gains the electron, it will gain a negative charge. Okay, and this compound is called as sodium chloride, NaCl, and this is an ionic compound formed by the metal sodium and non-metal chlorine. Okay, so here we can take an example, next example, that is the example of MgCl2. Okay, now the metal over here is Mg, and two chlorines are represented as non-metal. Okay, so we know that the atomic number of magnesium is 12 and the atomic number of chlorine is 17. Okay, so now what will be the electronic configuration of magnesium? It will be 2, 8 and 2. For chlorine it is 2, 8 and 7. Okay, now there are two electrons as the valence electrons over here, and over here the valency is 1. Okay, 1 for 1 chlorine. Now the valency over here is 2 electrons. So now what will happen? The magnesium has to remove 2 electrons from it to gain a complete shell. Okay, so it will lose 2 electrons, right? It will lose 2 electrons, but the protons already have the 12 protons are already 12 in the nucleus. Electrons after losing will be 10. So the magnesium will gain a +2 charge. In case of chlorine, this chlorine will lose, okay, it will gain the protons in the chlorine are already 17. Okay, electrons after gaining one electron will turn into 18. So chlorine will gain a negative charge, okay, minus charge. So this compound will be, so now we represent this in the form of a dot structure, okay. So over here we have 2 electrons. For magnesium we have 2 electrons in the outermost shell, okay, 2 electrons. And for chlorine, okay, in case of chlorine we have 7 electrons. Now the formula of magnesium chloride is MgCl2. So here 2 chlorines can be accommodated, okay, 2 chlorines can be accommodated because we have 2 electrons to be given. The magnesium can give 2 electrons to 2 chlorines, so that's the reason 2 chlorines can be taken. So this electron from the magnesium will go to this chlorine and this electron will go to this chlorine. This will lead to the formation of, okay, the compound MgCl2, okay. So now we have done 2 examples of ionic compounds, that is NaCl and the second one is MgCl2. So these compounds are called as ionic compounds, okay, they are called as ionic compounds. Now we need to study some of the properties of these ionic compounds, okay. The very important concept over here is the properties of ionic compounds. First of all, ionic compounds are made up of metals and non-metals, okay. Then they share a ionic bond between them, okay. They are also called as electrovalent compounds, ionic compounds or electrovalent compounds, okay. Now after that they are hard, okay. The physical nature of ionic compounds is that they are hard. Now why are they hard? They are hard because there is a strong electrostatic force of attraction. Now we can see that there is a positive charge and there is a negative charge which combines together, and we know that when there are 2 different charges combining together, these charges strongly attract each other, and when they attract each other they form a strong bond, okay. So there is a strong electrostatic force of attraction between the between the metals and non-metals. This makes the compound very hard, okay. So they are very hard, but they are somewhat brittle, means if pressure is applied to them they can be broken, okay. Now second thing is that their solubility, okay, their solubility. Ionic compounds are insoluble in water, okay, insoluble in water, but they are soluble in solvents like kerosene, okay. They are insoluble in water but they are soluble in solvents like kerosene. Now what you think will be their melting and boiling points? What is the meaning of the melting and boiling points? Melting points means the temperature at which the metal will start to melt, okay. Means that it should reach that temperature for it to start melting, and boiling means it should reach that temperature for it to start boiling. Now the melting and boiling points of ionic compounds are said to be very high because again they are attached by strong ionic bonds and strong electrostatic forces of attraction which keeps them bound together. and for melting they have to be released as ions. So that's the reason they have a very high melting and boiling point. Okay, then the last property of this is the conduction of electricity. Conduction of electricity. It is said that they are poor conductors of electricity in their solid state, okay, or in their true state, okay, in their original state or solid state. They are poor conductors of electricity. They do not conduct electricity. Why do you think so? Because for conduction of electricity we need freely moving ions. Okay, only freely, we have studied this in the last chapter also, that the ions and the freely moving ions are important for the conduction of electricity. But in the solid state, the ions are packed, okay, they are bound with the electrostatic forces of attraction, so they won't be able to conduct electricity. But in case of molten state, they are good conductors of electricity. Okay, in case of molten state. So what will happen in the molten state? In the molten state, when you melt, then they will overcome the forces of attraction between the positive and the negative charges, and they will be able to move freely and conduct electricity. Okay, so these are some of the most important properties of the ionic compounds. Okay, and most of the questions asked are the reasons behind their physical nature, okay, the reason behind their high melting and boiling point, and the reason behind their conduction of electricity only in the molten state. So yes, so this is a very important part in this chapter. And also the formation of ionic compounds are very important. The two examples which we did, NaCl and MgCl2, are also very important. Okay, so in the next video we will be studying more concepts on the metals and the extraction of metals, and how the metal is affected by the cues of the environment. Okay, so thank you for watching my video. Please like, share and subscribe to our channel.